In general terms, we can describe a linear programming model with the expression we have here. We have a set of variables x1 to xn, and there's a coefficient for each of those. In our case, that would be our benefit for each of those products we're producing, but this can be a cost, it can be anything that is relevant. So there is this parameter here that multiplies every variable in a linear manner. So what we had before is only two terms, but we can have as many terms as required by our system. And there are a set of constraints. In our case, we had 3, but we can have m in general, and all of those can be built as follows. There's a right-hand side, which is this v1, v2, vm, which in our case was the capacity we had for all 3 processes. And to our right, what we have is a linear expression, a linear combination of our variables with a different set of parameters per each constraint, that in our case was the consumption of resources involved in our production. So we have the unit consumption of resources per every item we were producing. And finally, we have to impose that all variables are non-negative. This is the way to formulate a linear programming model in general. We can also use a more compact form using a summations, okay? And we can create this expression here, which is exactly the one we have here, okay? But in a more compact manner. And we can also have this, which is this for all I represents that we can have a set of constraints, but all in the same form like the one we have here. And finally, we can resort to matrices to represent this this formulation, that is, or arise. So instead of using every single element of x, these parameters here and this here, we can substitute that using matrices. This is just for you to know that this extended version can be formulated in a very compact way as the one we have here.